Hello and welcome back to another one of our videos where today we are going to talk about leak testing automation, vacuum testing automation, and vacuum technology automation, as well as altitude simulation, also the automation and altitude simulation. So pretty much we'll talk about vacuum technology automation and how our products can help you achieve that. So today, let's talk about the system at first, and then we'll go more into detail. But you guys have seen these chambers before. This is a front-loading vacuum chamber. And you've also probably seen this. There are two fully removable perforated shelves. So these are removable and also perforated. And they're divided in thirds. So one, in 1, 2, 3, they're divided in thirds. In distance, so they're about equal. You have about 3 equally spaced compartments here, and so this is a front-loading chamber. It's got an ergonomic handle. It's got 2 door clamps that actually clamp this O-ring to create a hermetic seal to be able to engage the vacuum at first. And then on this side we have a manual vent valve, just a manual vent valve, and I'll talk about why we need this in a second. Then we have a solenoid vent valve, we have a solenoid vacuum valve, we have a digital vacuum gauge. And the reason we need the vent valve, like I said, is if the unlikely scenario, or in the unlikely event that both of these valves jam, you're not going to be able to open this door. There is, at 15 psi, you're talking about 16 times 16, because that's the size of this chamber, times 15, and that's quite a bit of force. I want to say about 4,000 to 5,000 pounds of force. So in order to open this without having to take off these valves, the easiest way to do it is to just use a manual vent valve. And like I said in my previous videos, it's actually a good engineering design practice to have a vent valve on your vacuum chamber. All right, so moving on, this is connected. There is a vacuum hose, bellows hose, that goes to this rotary vane vacuum pump, about 6 CFM, and this is all connected on a complete turnkey system. And this system comes table frame structure, 80-20 aluminum extrusions. I mean, 80-20 is awesome, by the way. You can build anything, any type of structure. 80-20 is cool. We use them all the time on a lot of our systems. And then lockable swivel casters. That means that you can move this system. It's portable. It's mobile. You can move it anywhere you want in your facility. So that gives you that additional option, that added flexibility. And all of this is powered by this brain, our latest and greatest vacuum controller. So the solenoid valves, the vacuum gauge, as well as a vacuum pump, is connected to this vacuum controller. And today, like I said, I promised you guys I'm going to talk about vacuum automation. We have a customer who has a requirement, and this requirement is they need to take this chamber to a equivalent of 15 inches of mercury. Then they need to hold it there for 3 minutes, which is 180 seconds. And then they need to, after that cycle is complete, they need to take it from 15 inches of mercury to 20 inches of mercury, and then hold it there for 3 minutes. And then after that, they need to take it from 20 inches of mercury of vacuum all the way up to 25 inches of mercury and hold it there for 3 minutes, and then vent. And that constitutes a cycle. Now, this is easy to set up on this controller. There's actually 3 steps here, just a step function where it goes 15, 20, 25. And for the sake of time being, I don't want you guys here to watch how it holds the vacuum for 180 seconds. We have set it up for 10 seconds. So we're gonna actually show you a live demo on how this works. So this is the current chamber vacuum. Now, remember I talked about inches of mercury, but we are measuring everything in absolute pressure. So 644 torr, since we're in Salt Lake City, Utah, that is about what our ambient absolute pressure is. And we're gonna take it to 15 inches of mercury, which is 381, oopsie, sorry. That was my fault, I am sorry, I accidentally pushed the button. So we're gonna take it up to 381,000 torrs, which is, I'm sorry, 381,000 millitorrs, which is 381 torr, right? And then hold it there for 10 seconds. You see that S, 10 seconds. And then once that's done, we're gonna take it to 20 inches of mercury, which is equivalent to 10 inches of mercury absolute, which is 254 torr. And then we'll take it, hold it for 10 seconds, and then we'll take it to 127 torr, which is 25 inches of mercury of vacuum, which is 5 torr of absolute, and hold it there for another 10 seconds. So let's get started. Here we go. Chamber vacuum, you hit F1 and it starts pumping down. You'll notice the vacuum is going down, 620. And I forgot to say, it's actually at 15 inches of mercury or 381 or better. So what happens is that the moment this reaches 381, the valve will close and the timer will start. So here we go, we had 500, 400. And you can kind of see it here. And so we're pretty much getting there. Here we go, 430. And the moment it passes 380, the valve is going to close. Listen to it. Right there, it closed it. So it closed it, and now the timer has started. You guys can see the timer is going. We're at about 375, so it's very close. And now you'll notice that it went from step 1, now it's going to step 2. And the target vacuum is 254, so it's going to go to 254. And the moment it reaches 254, it's going to start the countdown again. I'll kind of show you here. All right, listen to it again. You're gonna hear the valve click. Right there. So we closed it. There we go. And the timer is running 6, 7, 8, 9, 10, and it's gonna open again. Bam, right there. And then the final step, you'll notice how it goes, there is this filled out square. So that means we're on step 3 and we're pumping down. And you'll notice that it started, there was a filled out square here, and then it was here, and now we're on step 3. And step 3, it is going to go to about 127 or better. And the moment it gets there, it's going to close the valve. And that is it. And so this is the whole thing. Pretty cool, isn't it, huh? Here we go. Oh, here we go. Right there, closed it. And here we are. So it's gonna hold it for about 10 seconds. 7, 8. And now it's venting. All right. So we are pretty much back to ambient. The chamber has fully vented. And remember, I said it needs to hold for 3 minutes. So let me show you how you can set it up. Here you can set your target pressure, the first step. And here's the hold time. And we need to go to 180. So I'm gonna hold it 180. That's the first hold time. this is 180 the second hold time, and then 180 the third hold time. Here we go. So now you'll notice that the numbers, remember at the beginning they were 10, now it's 10 seconds. That's the set point. I'm sorry, it was 10 initially, now it's 180 seconds for each cycle. And you'll notice all of these 3 boxes on top, these guys, they are blank. They're pretty much not filled in, but when you hit start, you're gonna see that it starts here, meaning it starts the cycle 1. So yeah, there you guys have it. This is pretty much it. Oh, and of course, before I forget, you can exit this screen. And then you have a vacuum controller. I just want to show you guys an option. So that's an option. This is the standard option we have, which is the vacuum controller. And what it has, it has an altitude simulation, meaning it gets you to the altitude, holds it for your set amount, and then after that it releases the vacuum. And so here the set altitude is at 92, which is about 49,000 feet. The dwell time is 30 seconds, and then you want to hold it there, or you also have ascent rate, you have descent rate, and then when you hit start, it's going to start taking you there. But you know, we're not gonna do it. You guys have seen it on our other videos. And then another cool thing is you can hit F5 here and you can go manual mode, meaning here's the pump, here's the vacuum valve, and here's the venting valve. Cool, huh? All right, so there you guys have it. Sorry, I kind of split these 2 functions with this controller. This controller enables you to do the ASTM altitude simulation test for packages for high altitudes, and it'll take you as high as this vacuum pump will allow. And this is a rotary vane vacuum pump, and you can get up to 200,000, 250,000 feet of altitude equivalent. So it's quite a lot with this type of a vacuum chamber vacuum system. All right, I think we have covered everything. I think this is it. So like I said, vacuum automation, automate your package testing, automate your quality control, automate your altitude simulation with our latest and greatest altitude simulation system, or vacuum chamber and pump, or automated vacuum chamber and pump system. All right, I think this is it. So thank you guys very much. Thank you for listening. Thank you for watching. Thank you for liking and subscribing and leaving all your comments. I really appreciate it. And also, thank you for being our customer. We love working with you guys. We appreciate what we can do for you guys, and we appreciate you guys' business. All right, you guys have a good one. Bye-bye.